Hi you guys, this is the Trig Day 3 lesson on angles, not angels, angles. Here is the definition of an angle. This should be a review from geometry, but an angle is formed when a ray is rotated around its endpoint. The common endpoint is called the vertex, and you can see the vertex in the picture that's below. The ray in its original position is called the initial ray or the initial side of the angle. And then depending in this picture, we could kind of think of this ray down here as our initial ray. But that's assuming that we're looking at a positive angle, so an angle that's rotated in the counterclockwise position, which we've only talked about positive angles so far, but in a second we'll talk about how we get negative angles as well. Now the ray after it is rotated is referred to as the terminal ray of the angle, or the terminal side. If the rotation of the ray is in the counterclockwise direction, like we've been looking at so far, then that's going to correspond to a positive angle. All the angles that we've looked at in the unit circle so far have been positive angles, so angles that have been created from rotating a ray counterclockwise. But if a rotation is in the clockwise direction, that actually creates a negative angle, okay, which you can see in the picture on the on the right-hand side. So we want to become as familiar with angles as possible. What I told the class today is that in the early stages of your math career, like in pre-algebra, a little bit in Algebra 1, you guys work to develop your number sense. And now I want you guys to try and work to develop your, for lack of better words, your angle sense. So where you can picture an angle in your head and kind of visualize which quadrant it would terminate in, or maybe it doesn't terminate in a quadrant at all. Maybe it terminates on the X or the Y axis. But to be able to kind of visualize that in your head and have an understanding of the angle. So 400 degrees, that's more than a single rotation, right? Because a full rotation is 360 degrees. So if I draw the picture here, okay, let's say this is our initial ray, and the angle 400 degrees, okay, here would be a full rotation, and then it's going 40 degrees past a full rotation, so let's say it terminates there. So here would be the terminal side of the angle, or the terminating ray. So 400 degrees ends up terminating in quadrant 1. Okay, so negative 150 degrees. Let's draw that picture. Now 150 degrees we know terminates in quadrant 2. But if we're thinking about negative 150 degrees, here would be our initial ray, and then in quadrant 3, we would have our terminating ray, so that angle right there would be approximately negative 150 degrees. So in quadrant 3, negative 150 degrees terminates. Right, this would be approximately positive 150 degrees. Okay, and 7 pi over 12. So the way that I would determine which quadrant 7 pi over 12 terminates in, pi over 12 is not an angle that lies on the unit circle, but it is half of pi over 6, so it corresponds to 15 degrees. So for pi over 12, remember when we were deriving the unit circle, for example, we counted pi over 6, 2 pi over 6, 3 pi over 6 corresponded to where pi over 2 was, 4 pi over 6, 5 pi over 6, and so on to fill in those angles on the unit circle. Well, 6 pi over 12 would end up corresponding to pi over 2. Let me draw that picture. Okay, so the angle pi over 2 is equal to 6 pi over 12, right? 6 pi over 12 would simplify to be pi over 2. The angle pi, so this angle right here, so the angle pi is equal to 12 pi over 12, right? Because 12 pi over 12 was simplified to be equal to pi. Well, 7 pi over 12 is going to lie between 6 pi over 12 and 12 pi over 12, meaning that the angle 7 pi over 12 is going to terminate in quadrant 2. And the last angle on this example is negative pi over 2. So negative pi over 2. This is our initial ray. Our terminating ray would be here. Terminal ray would be here. So this angle rotating in the clockwise direction would be negative pi over 2. We know pi over 2 in the counterclockwise direction would be this angle. So negative pi over 2 terminates on the, not in a quadrant, but in the, on the negative y-axis. So not in quadrant 3, not in quadrant 4, but on the negative y-axis. Okay, so coterminal angles. Coterminal angles are going to be really helpful for us to evaluate the trig functions for angles that are not on the unit circle, but angles that may have coterminal angles that are angles on the unit circle. So an angle, two angles are coterminal angles if they terminate in the same place. So if we have two angles that are in standard position, meaning that their initial ray lies on the positive x-axis, and each of those angles terminate in the same place, then we refer to them as coterminal angles. And every angle has infinitely many coterminal angles, and you can keep finding additional coterminal angles by adding or subtracting 360 degrees or 2 pi radians, depending which units you're in, to find additional coterminal angles. So for example, let's say we have the angle, how about negative pi over 2, like we just looked at? So this is the angle negative pi over 2. Now the angle that lies between 0 and 2 pi that is coterminal to negative pi over 2 is the angle 3 pi over 2. And if we took that angle negative pi over 2 and we added 2 pi, which I'm going to add 4 pi over 2, which is equivalent to 2 pi, notice that we would get 3 pi over 2. Okay, so 3 pi over 2 is coterminal to negative pi over 2. Now, remember, we defined the 6 trig functions as ratios of x, y, and r. So x and y are values in the xy plane, right? So ordered pairs in the xy plane. And r, remember, is the distance of a point in the xy plane to the origin. So if an angle terminates in the same place as another angle, they're going to have those same ratios for x, y, and r. So for example, if we wanted to evaluate, how about sine of negative pi over 2, that would be equivalent to sine of 3 pi over 2. And 3 pi over 2 lies on the unit circle, right? So if we went to 3 pi over 2 on the unit circle and looked at the y value at that point, we would see sine of 3 pi over 2 is equal to negative 1, meaning that sine of negative pi over 2 is equal to negative 1 as well. Okay, so it's usually helpful for us to find coterminal angles. So if an angle is larger than 360 degrees, or if an angle is less than 0 degrees, it's helpful for us to find the angle that would lie between, its coterminal angle that would lie between 0 and 360 degrees to help us be able to use our unit circle to evaluate any of the trig functions at that given angle. So here's our process that we follow. If the given angle is larger than 360 degrees, then you can keep subtracting 360 degrees till you're at a coterminal angle that lies between 0 and 360. If the angle is negative, then you can keep adding 360 degrees until you're at an angle between 0 and 360. If you're in radians, then you're adding and subtracting 2 pi. Okay, so let's go ahead and find the angle with the smallest possible positive measure that is coterminal with each of these angles. So 900 degrees is more than a single rotation. So if I subtracted 360 degrees from 900 degrees, I would still be at an angle that would be larger than 360 degrees. So I'm going to actually subtract 720 degrees, which is 2 times 360 degrees. So when we do that, we get 180 degrees. So 180 degrees is coterminal to 900 degrees. All right, negative 430 degrees. We could add 360 degrees, but we'll still be in the negatives. So let's add 720 degrees, and that'll put us, I believe, at 290 degrees. Remember, don't forget your degrees. And negative 13 pi over 6. Well, if I add 2 pi, so if I add 12 pi over 6, I'm going to be at negative pi over 6. So we have to add 4 pi, which is adding 24 pi over 6. And when we do that, we'll get 11 pi over 6 as the coterminal angle to negative 13 pi over 6, meaning both those angles terminate in the same place in the xy plane. All right, reference angles are not very useful. However, I want you guys to know the definition of a reference angle and how you can use a reference angle, mainly for standardized test purposes. We're going to kind of think about reference angles when we're looking at some applications later on. But really, if you're determining a reference angle for a given angle that's in standard position to evaluate a trig function, you might as well just determine the do the calculation to determine the coterminal angle that lies between 0 and 360 or 0 and 2 pi. But here's the definition of a reference angle. So the reference angle of an angle that's in standard position, meaning that its initial ray lies on the positive x-axis and its terminal ray terminates at 0 degrees or at the x-axis or somewhere else in the xy plane. So to find a reference angle of an angle that's in standard position, it's the positive acute angle between the horizontal axis, so the x-axis, and the terminal side. Okay, so this information is important for determining reference angles. So let's look at these given angles, and we're going to determine the reference angle for each of them. So for 150 degrees, this angle right here, notice it's positive, so I'm showing the angle rotating in the counterclockwise position, and it's also an acute angle. It's an angle that you would find in quadrant 1. So this angle, reference angle, is equal to 30 degrees, and I can get that from 180 degrees minus 150 degrees. All right, the reference angle for 255 degrees would be this angle here, and positive acute angle. So the reference angle is 75 degrees. Okay, 255 degrees minus 180 degrees in this case. All right, 7 pi over 3 is more than a full rotation. So starting here and coming around, well, that would be 6 pi over 3. And then it looks like we're going an additional pi over 3. So the reference angle is going to be pi over 3. And it's actually, pi over 3 is also the coterminal angle to 7 pi over 3, right? The angle pi over 3 and the angle 7 pi over 3 terminate in the same place. And both are in standard position. Okay. For negative 3 pi over 4, here is our reference angle. So it would be the angle pi over 4. And here's how we can use our reference angle. So let's say that I wanted to find cosine of negative 3 pi over 4. So from a reference angle perspective, we could think about cosine of pi over 4. Well, cosine of pi over 4 is root 2 over 2. So we know that cosine of negative 3 pi over 4 is either going to be positive or negative root 2 over 2, depending on what the sign of cosine is in quadrant 3. Quadrant 3 because that's where the given angle, negative 3 pi over 4, terminates in. So we think back to all students take calculus. So in quadrant 3, cosine will be negative. So cosine of negative 3 pi over 4 is going to be negative root 2 over 2. I like to think of, I would prefer to evaluate negative 3 pi over 4 from a coterminal angle perspective, where if I want to know what cosine of negative 3 pi over 4 is, that's going to be equivalent to cosine evaluated at its coterminal angle. So negative 3 pi over 4 plus 8 pi over 4, which would be cosine of 5 pi over 4, which we know is negative root 2 over 2 from our unit circle knowledge. All right, we're going to skip this example. And we're going to go right to evaluating the trig functions. Now again, I do not suggest using reference angles. If you like reference angles, that's okay. You're going to be able to evaluate the trig functions correctly. But the thing is, you just need to be really careful about your signs and making sure that you're finding the correct reference angle. I think that can also be challenging. So what I suggest doing is determining the coterminal angle. If the angle is outside of that 0 to 360 degrees, then finding the coterminal angle that does terminate in between 0 and 360 degrees, or between 0 and 2 pi. So sine of negative 480 degrees is equal to sine of negative 480 degrees plus 720 degrees. Okay, so 720 minus 480 to, oops, why did I put 3? It's 6. 240 degrees. Okay, so sine of 240 degrees, that's going to be negative root 3 over 2. Okay, also remember we're trying to wean ourselves off of having to have the unit circles in front of us. We want to get to the point where we can just visualize the unit circle to help evaluate the trig functions for those angles. Okay, so cosine of 23 pi over 6 will be equivalent to cosine of 23 pi over 6 minus 12 pi over 6. Okay, and that will be cosine of 11 pi over 6, which is equal to positive root 3 over 2. All right, 900 degrees we've already looked at for the coterminal angle. So secant, that'll be secant of 900 degrees minus 720 degrees, which we said earlier, 900 degrees minus 720 is equal to 180 degrees. Secant is the reciprocal of cosine. Well, cosine of 180 degrees is negative 1, so the reciprocal of negative 1 is just negative 1. And last one, cosecant of negative 10 pi over 3 is equal to cosecant of negative 10 pi over 3 plus 12 pi over 3, so that's the same as adding 4 pi. So that's equal to cosecant of 2 pi over 3. Cosecant is the reciprocal of sine. So sine of 2 pi over 3 is root 3 over 2. So the reciprocal would be 2 over root 3, which if we rationalize, we get 2 root 3 over 3. Okay, so make sure you guys are still studying your unit circle. On Friday will be your unit circle quiz/contest where you need to be able to fill in all of the angles and degrees and radians, all the points on the unit circle, as well as all the values for tangent around the edge of the unit circle. Okay.